Thank you for that, Paul. We have another question, this one from Torsten Vidal. And he has been studying the Arctic sea ice, as you know, and he said the most shocking news on the ice forum in February was how the atmosphere layers over the Arctic changed over the last couple of years. They used to be, I guess the coldest mile of air would be closest to the ice, and he wants me to ask you about the changing layers of atmosphere over the Arctic, and if you thought that what was the prospect of the ocean layers also changing in a similar way.
Yes, so we've talked briefly about this, and it needs a lot more thought. But what we do know is that, generally over the Arctic, when there's lots of sea ice cover over the Arctic Ocean, then rather than having a marine climate, which you have over bodies of water, it becomes more like a continental climate. So over continents, in the winter, you get tremendous amounts of heat radiation loss from the surface, especially if you're up in the Arctic where it's very dry. So there's not a lot of water vapor in the atmosphere. There's not a lot of clouds. There's not a lot of things to keep that heat trapped. So we get tremendous amounts of long wave radiation loss from the surface in the Arctic. So the surface is extremely cold, and you get this, if you like, a big sort of an enormous cold layer, very cold air over the ice, which is cold air is dense. So you basically have sinking air. You have very high pressure over the sea ice, and when you have high pressure there, you therefore have lower pressure all around on the continents. So the air wants to move from the high pressure area to the low pressure area, so it creates the winds. And because of the Coriolis force, which turns things to the right in the northern hemisphere, air leaving that high pressure area from the North Pole is deflected to the right. And what it does is it forms a clockwise gyre, if you like, a clockwise motion of the air, and that generates a clockwise movement of the ice itself, and it's called the Beaufort gyre, and that's the normal state. When I say normal, that's the usual state of the Arctic. Now, the Beaufort gyre, moving clockwise, it feeds in some of the air, spins off and creates what we call the Transarctic drift, which is basically almost straight line wind spinning off the Beaufort gyre heading out into the North Atlantic. So that's the sort of circulation pattern of the winds, and then that moves the ice. I mean, the ice is dynamic. It moves. It's pulled along by the frictional forces of the wind, and then the ocean currents are generated underneath, and so on. So that's the state that we would have. Now we need to contrast that to a state where the Arctic has no sea ice at all. So in that case, we've just got open water in the Arctic Ocean, and then we'll still have and it's surrounded by the land, of course. Siberia, northern Canada, the islands, the Canadian archipelago, etc., Greenland. So what happens in this case is, well, let's consider what happens after the summer, when that water's being warmed up, and because the water's warmed up, there's a thermocline, so the water's very hot at the surface, and it gets colder as you go down, and warmer water, and it's going to be fresher from the melt, is very light, so it floats on the surface. So there's not a lot of mixing in the water at that time. But what happens is, as we go into fall from the summer, then the air temperature drops and the continents cool down a lot faster, and the ocean is a lot warmer than the continent. So because the ocean is warmer, the heat rises up and it creates a low pressure area at the surface above the ocean. So this is a reverse situation to what I previously described when there's ice on the surface. So we have a low pressure at the surface, So therefore it's higher pressure all around. That higher pressure air moves in towards the North Pole, deflects to the right, and it creates a gyre which is spinning in a counterclockwise direction, which is in the opposite direction to the, what we're used to, the Beaufort gyre. And by the same token, that will reverse the transarctic drift. That will pull air in from the North Atlantic. So the water and the air will then drag the water currents in those directions. So what we get is basically a reversal of the existing air circulation patterns in the Arctic. So what does this mean? Well, one of the things is you need to look at the actual geography or the geometry of the land ocean areas and try to determine, is more warm water going to be pulled into the Arctic Ocean basin from the new state with no ice versus the old state when there was ice. And for example, the transarctic drift will pull water in from the North Atlantic into the Arctic Ocean basin, probably more surface water than came in before. So if that water is warmer than the water that was previously pulled in, then that will, warm the Arctic even more and prevent any ice from forming and at all, like year round. This is the sort of thing that we need to look at. And then there's also the other thing is that the the Atlantic Ocean is generally saltier than the Pacific Ocean, and saltier water is heavier, so the sea surface height is a bit lower. So this tends to lead to more flow of water from the Pacific Ocean through the Bering Strait, into the Arctic Ocean. And, previously water would be flowing out of the Arctic Ocean into the North Atlantic, carrying ice with it. So if that state is, there's all kinds of different factors that are under play. In terms of the water column, with no sea ice, there's tremendous wave action in this ocean. We've got a vast ocean, and we can have large swells develop and large waves and winds, and the waves tend to mix. They tend to break up the stratification of the ocean layers. With the hot water on top and colder water below, you get more mixing down below, and we're already seeing massive changes in the behavior of the ocean over the very shallow continental shelves where the ice is basically gone year round now. So over the eastern Siberian Arctic shelf, the water temperatures down to the 50 to 100 meter sea surface depth, or seafloor depth rather. That water is being mixed, and I think Peter Wadhams was saying it was parts of that shelf were 4 or 5 degrees Celsius warmer than they've normally been. So
well, if that shelf is so much hotter and there's so much methane hydrate deposited there, it would seem to me that it's going to thaw, and that we will have a methane emergency on our hands. Can you talk to us about that?
Yeah, I mean, this is this has always been kind of the wild card, of the climate system. It's the methane, and Wadhams did his paper. I guess that was in 2013. It was a while ago. About a 50 gigaton burst of methane, and this is based on some of the work being done by. I mean, the Russians have been doing they've been making research trips out onto that shelf for many decades. In fact, measuring methane changes and so on. So then the big question becomes is, how much of that methane gets up into the air? I mean, if that 50 gigatons, if the methane is coming out across the, Arctic region, widespread across from the shelves, if it's bubbling up, then there is the question of how much of the methane will be broken down in the sediments as it's bubbling up through the sediments in the water column, from decomposition, aerobic decomposition in the water column, and you know, how much will be dissolved in the seawater, and stuff like that. So if it's coming up in, you know, if it's coming up in pockets, you know, highly concentrated pockets in very small regions, then you know, it will certainly saturate all of these mechanisms that remove it, and a lot more will come up. If it's coming up, you know, widespread from all different regions, you know, at lower rates, then there's more of a chance that you know, it can be decomposed and broken down, larger percentages of it. You know, and then there's also the, you know, I guess in the winter when there's the ice, you know, methane that's coming up, some of it can be trapped, you know, under the ice and be released, you know, over time as the ice is thawing, depending on, you know, where, how thick the ice is that it's underneath, and so there's lots of, you know, there's all kinds of different fact. I guess there's at this stage, I mean, I mean, there's always going to be more questions than answers, I think. You know, we just have to try to figure out as much as we can about all of the different mechanisms, and, you know, come up with some reasonable, you know, scenario or viewpoint of how it's all going to play out.
Okay.
Right? So,
Yeah.
I mean, Wadham said, you know, 50 gigatons would cause a $70 trillion impact to the global economy. Right? You
The
know, this
news
would be,
just doesn't look good. I mean, there's shortly going to be a lot more answers too, because these things are coming out, and we're saying, well, we don't know exactly how it's going to play out, but we're going to know how it's going to play out, because there's everything's hotter, and it's going to play out, and we're going to watch it.
yeah. Yeah, I mean, we're going to see, and I guess, there's always the question is, I mean, our global population is still going up at 1.4%, which is 240,000 people a day, births minus deaths increase, and it's, I mean, the stresses to our life support systems, to our growing food and water and everything else, I mean, are ever increasing. So, but the whole system, I don't think the whole system snaps in, simultaneously.
Hmm.
like
No,
like
I think it's
we're,
it's it's death by a thousand cuts, and nothing goes down all at once. It's like, oh, this area has
yes,
become very problematic, very dangerous, uninhabitable, too hot to grow food, take your pick, flooded, and then it's kind of like, where are the good areas that are left? And we'll see.
yeah, I mean, it's I mean, countries have huge variation in their resilience. I mean, there's articles about food supplies in a number of different African countries, with projections of maybe, we're talking tens of millions of deaths by starvation, just no food in some of these countries. And these projections are even, they're from, they're very near term projections, maybe, within a few years, right?
Well, let's